this video, we are going to see about battery cooling methods for electric vehicles. There are a number of battery cooling techniques are available. It is one of the most important functions of a battery thermal management system in electric vehicles. During charging and discharging, lithium-ion batteries generate heat due to uh, internal resistance and electrochemical reactions. So, if this heat is not removed effectively, the battery temperature rises, which reduces the efficiency and also accelerates the battery aging, and which results in decreasing driving range and the increasing the risk of thermal runaway. So, it is very mandatory to maintain the battery within the ideal operating temperature range, that is usually between 20 degrees Celsius to 40 degrees Celsius. Let us see one by one about the different cooling methods. So first one is air cooling or natural forced convection. So you can see in this diagram, this is the battery pack. So the heat produced by this battery pack is can be removed by the natural air or forced air that can be made to flow through this battery pack by using a fan or blower, so that the heat is transferred by the air flowing through this battery pack and easily it can be dissipated to the outside atmosphere. So the important features includes it is very simple and low cost with lightweight, and also as it is a simple method, it is very easy to maintain and for suitable for low power or moderate power applications. The next one is liquid cooling or direct or indirect method of liquid cooling. So here you can see this is the coolant inlet and this one is the coolant outlet, and these are all the coolant channels. A liquid coolant liquid is made to flow through these channels. So when it get into this channel, the batteries inside this channel, battery heat from the battery packs is getting transferred to this coolant, and that heat is further suppressed through this heat exchanger. A pump is specifically provided to make this liquid to flow this circuit. Okay, so this is about liquid cooling, and it has a very high cooling efficiency and better temperature uniformity. So that it can be used for very high power and fast charging DC charging methods also. So this is what about liquid cooling. And the next one is the phase change material based cooling. So the yellow color indication is the phase change materials, which has the property of uh, converted into solidification, getting converted into solid to liquid state. So when the heat absorbed by this material, it converted into solid to liquid state, and once the heat is when the battery pack heat is getting low, then it again cools down, so it gets back to its solid state. So this type of cooling method requires no any mechanical or devices or any mechanical operations, so there is no wear. And but it has one main limitation that the cooling efficiency is somewhat less. There is it also it adds some huge weight because of this material weightage. Okay, so then next one is heat pipe cooling. So this heat pipe is attached with the thinner heat sink. So the battery pack heat is getting absorbed by a coolant through this working fluid through these pipes and getting dissipated through this heat sink. So features we can use, we can have high effective thermal conductivity in this method. It's a passive system and good for hotspots, which increases the number of cost increases if we increases the number of heat pipes for better cooling. Okay, then immersion cooling. This is a direct method of cooling in which we are making the battery pack to immerse in a liquid. This is a dielectric coolant liquid, so it is a non-conductive liquid, so there is no any uh, possibilities of short circuits of the battery cells terminals. So entire battery pack is immersed in the dielectric coolant, so heat is transferred directly to this coolant, and the coolant is made to flow through the heat exchanger to dissipate the heat. So it is excellent cooling. It has excellent cooling efficiency. Very uniform temperature can be maintained inside the battery pack. Allows very high energy density, also complex sealing and high provides very high cost due to this complexity of shielding. It requires requires dielectric coolant is also a challenge. Proper dielectric coolant and its dielectric property to be also maintained for this lifetime. And the next one is thermoelectric cooling, which is also called as Peltier cooling. So this Peltier module is made up of semiconductor. It has two sides. One is hot side and another one is cool side. This cool side, the battery pack is connected in the cool side of Peltier module, and another side is the hot side in the heat sink is connected. So from the heat sink, the heat is dissipated to the atmosphere. So these are all some kind of cooling methods that is uh, widely used for battery cooling methods. Um, so please go through this and we will see with some other topic in the next video. Thank you.